Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about rocket launch tower, the most ignored part of the rocket system. So let's dive deep into it. Now you have to understand that there is a serious need for this. You cannot design a rocket without a launch tower. And here's the problem. All of the rockets are getting bigger. Meaning there was a time where I was like, okay, let's make a rocket smaller. Now we are going in the opposite direction. It's like, what if we make it bigger? It's like, here's the, what if we make it even bigger? What if we made it huge? What if we made it fat? So it's getting huge out there. And here's the problem. The launch frequency is also going up, meaning when SLS was designed, the whole principle, the structure and everything around it was designed in such a way that you're going to launch it and then you're going to have your sweet time in order to first analyze it, what the hell went wrong, what broke up, take 1 month to analyze every nut bolt and all that, spend 2 to 3 months repairing it, test it, and then it will be ready for next launch. That was okay when you are doing governmental contract. That's not okay for this. And you can easily see its result in SpaceX Launch Tower 1 versus Launch Tower 2. Launch Tower 2 is overbuilt like hell. Why? Simply because of the frequency part. You again, NASA's operation and Starship's first launch tower, they were the same. Every launch you had to do inspection, every launch you had to do repair and refurbish. That's how NASA designed it, because again, their target was, we barely have enough rocket to launch like, once a year, let alone like multiple times a year. But again, in this, you had to do it differently. So look at the Launch Tower 1 versus Launch Tower 2. It's overbuilt like crazy, and it has to be. Otherwise, frequency cannot be maintained. And then there are unique requirements, and sometimes unique requirement based on each rocket system itself. And you may have to deal with human and their hassle, so to say, and it must survive fury of the rocket launch. So it's not something that is like minor inconvenience, it's major inconvenience. So this puppy has to handle a flame torch going YOLO on it safely. Yeah, that's brutal. Let's just put it that way. And all the quick disconnects, everything, it has to support it. And sometimes it also needs to be mobile. Okay, let's expand each of the vectors. So umbilicals, this is the most easy to spot parts. And again, if you ever want to see overbuild like super duper complex engineering, look into ISRO's launch tower. The umbilicals are like, damn, it's like Soviet Union had infinite money, that kind of design philosophy. So liquid fuel rockets have to be fueled just before launch. Basically, if T0 is 1 hour away and they know that they can fuel the rocket in 30 minutes, they will start fueling the rocket, let's just say 35 minutes earlier. You do not want rocket to be fully fueled and stay there for a long time, unless weather causes an issue or some other fault causes an issue. That's not desirable state. So you always do refueling at the pad, and launch tower is the only thing that can do that. Not only has to support the rocket at that point in time, it has to handle all the propellant, which again, sometimes it could be mild like liquid oxygen, sometimes it could be brutal as hypergolics. So it has to handle all of that. And yes, you can in principle have hypergolic preloaded, not recommended. Depending on the design, depending on the amount, depending on concentrate, you can deal with it. Although solid boosters are treated as live because they are live, meaning they can go kaboom at any moment in time. They are live. And whenever we are talking about propellants, specifically cryogenic propellant, there's this one mess that we have to deal with, that you must have a return line, and generally return line would be huge, or it will be sucked by a lot of blowers. Basically, you do have to understand, whatever rocket you are talking about, it's on ambient temperature, and ambient. And I'm not talking Indian ambient. Ambient as in like even American ambient, it would be what, 10 degrees Celsius? The moment you dump something that is minus 100 degrees Celsius or minus 200 degrees Celsius, yeah, that's boiling. So it goes from liquid to gas instantaneously. It's like whoosh, and you have to keep sucking it away. Otherwise, A, you will overpressurize the tank. B, you're gonna go kaboom. So we have to evacuate it. Of course, you generally control it. It's a controlled process, so you can maintain enough pressure so sloshing is not happening too much. All of that is controlled, monitored, and then you collect the boil off. And be mindful, in most launches you will see a flare that is burning, and it does not make sense why the heck there is a fire there. It's generally to boil off gases. Like, why? Well, here's the deal. When you are boiling off methane, it can because it's cold. It is a gas, but it's cold gas. While it went from liquid cryogenic to ambient temperature, it's still kind of cold. So it can collect in that local area. And when you fire the rocket, it will go kaboom. So people have learned this the hard way, that if you have a flammable gas, either contain it inside, or if it has to be released to the atmosphere, set it on fire. And methane is a greenhouse gas. So it's so bad that it's like, bro, just burn it. Carbon dioxide is manageable. So that's why you'll always see a flame trench. A, it's a fire suppressant system. B, it's environmentally friendlier. Ideally, you will collect it, but we haven't built that sort of system yet. It will be done. I do expect Starship to do that because their boil off would be so much. It's like they have to do it. If they actually do multiple launch a day, they have to like create giant tanks that can handle gaseous system or have a ginormous compressor that can work at that sort of flow rate. It may be doable, but they have to. Again, if they actually touch the point of like once a day, boil off alone would be causing them too much money loss. Electrical and telemetry connection. Now, all the rockets generally have a big ass battery. The batteries is generally their boosters have a very easy job because it's like, hey, battery turned on, start counter, count for 5 to 10 minutes, done, go home. There is nothing more to do. Even booster landing is generally done under that 10-minute period. So your battery is only good for that. And again, for weight saving, they generally do not make this battery far more capable. If they need, let's say, 3-unit battery, as in 3 kilowatt hour, they'll put 5. They will not put 30. Meaning, when it's on the launch pad, it has no power source and it needs power source for calculation, for timing, safety critical systems, including boom devices. It must maintain stable charge. So, umbilicals also include electrical wiring that provides the main baseload power. And then you have telemetry connection. So, these are the bulk power that you are dealing with. And this is how, when you see the control center, people are like, how the heck they know what's happening with the rocket? That umbilical has that telemetry paper, and electronic is making sure the battery is fully healthy, fully ready to go without being drained before launch. So, and some payload also require air conditioning. Now, generally it's a hassle because you may want to think, hey, what if I vacuum it? Yeah, if you pull a vacuum inside a fairing jettisoning phase could become compromised or messy. So generally they're like, okay, let's create a control. So let's say you have to launch James Webb Space Telescope. You will make sure the air that is in it is dry as hell. That cannot be maintained on Earth reliably. So it has to be actively maintained, meaning once James Webb is put on the rocket and like you sealed it into the capsule, you will start running the dry air system and it will constantly running. While it's on the tower, it will still be running. It will only shut off when it's like launch, like T0, only then it disconnects it. So you have to maintain it. That's the only way they can make sure, because if moisture gets there, moisture has this tendency, half of the moisture will turn to vapor instantaneously. Like, okay, if you go into vacuum, fairing doors opens up, that partial pressure that was there, it will get, released. It will go into vapor, cool, awesome, nobody cares. Yeah, the remaining will become ice. And ask NASA how they know that is a big issue, how many optics issue they had to deal with when trapped moisture became ice in optics. So people have learned it the hard way that it must be dry AF. So it does require launch towers to support it for hours or sometimes days. And this also goes for basically astronaut. You do not want the main system to drain its own energy banks because it's not in orbit, solar panel has not been deployed. You will be draining the battery if the astronaut cooling is done via the main system bus. So you always want to do it by aux. And worst case scenario was Space Shuttle and Saturn V. They did not have solar panels, so they had hydrogen. So if you remove the umbilical, system will work. It was designed to work. They'll be like, yeah, my man, you have 10 days of hydrogen supply, hydrogen fuel cell supply. Yeah, you wasted half of the day just on launch pad. Not acceptable. So fundamentally, that's why umbilical connections are not just like put it, like you have to design the whole mission around it. And all of this has to disconnect at T-0, all of it, and in sequence. There are certain clamps, so to say, that does not launch even though rocket is going fully yellow. So for example, booster ignition, rocket launch, no, that's not how it works. Booster ignition, then it stays on the clamp. Clamps are almost like a load sensor where they're like reading it. It's like, are you strong enough? Because here's the deal, rocket gimbals can only work if they are in thrust vectors, as in like they're pushing it, gimbals are like, I got you, I can maintain the rocket. If they do not have enough oomph and you open the clamps too early, yeah, it's gonna fall back and kaboom. Don't ask NASA how they know. Enough booms have happened. So they're like, clamps will hold you. It's like, I will not let you go unless you provide 100 or 3% of thrust that is needed. So you have to make sure that systems are above absolute, that it will work if I launch the clamp. It will not fall back. So all of this has to be done. And some umbilicals would be absolute last minute. It's like, some ones would be like, go YOLO. Others would be like, okay, are you sure? Are you really sure? Then it will happen. And all of these are precisely timed. So they have a sequence. When one door has to be opened, 1 second door has to be, all of it. Has to be very strong. And umbilical is so important, they also have command override, as in if umbilical systems, as in the computer commands, the circuit breakers, all of them detect a fault, they will abort the launch. Like flat out, it has the ability to override the T countdown. It will like, nope. And you want it. Like you want, if it detects like battery box number one, number two went kaput, yeah, the end. Launch, the end. So fundamentally, umbilical does have that authority. Of course, you could try to override it, but you have to reset it. It will not allow you to like, who cares? No, you have to reset it properly. That's why whenever you see the pilot systems and it's like there is a reset button, like master caution button, then you have to reset it. Only then it will allow you to go back to doing what you're doing. It's like an acknowledgement state. Have you acknowledged that something bad happened? So it does have that power. It's like, nope, it can just nope the launch. Now we come to the structure part of it. Yeah, the structure part is not that difficult, so to say, even though it's big and all that. It's just that it's boatload of steel and boatload of concrete. And I'm pretty sure Starship has a lot of concrete. They are using speed core. If you want to figure out how they are building it, they are using speed core, meaning we generally use steel just for forming concrete, and concrete is the main structure. Speed core is, what if your steel has structural strength and then you fill it? It's a like composite of steel and concrete. Much stronger, even stronger than rebar structure. So that's why it looks like Starship structure. It's very strong. So steel and concrete, it's not that difficult. But again, you cannot cut cost on it. This is one of those things that at larger rocket, this becomes an exponential problem. And this will explain to some extent why when NASA was like, okay, we had one tower, we are building another one. Yeah, that should be bid for $300K dollars. And yeah, it costed $1 billion and not a single metal has been welded to this date. So because you need bespoke launch tower for each rocket system. For every rocket, it's a very finicky thing. Every rocket needs a different, like SLS, block 1, block 2 needs different. Okay, Starship, everything needs different. What about basically normal Falcon 9 system? Yeah, that will not work for Falcon Heavy. Every rocket is different. So launch tower cost is a very, what you call a sneaky cost. If you're like, hey, I'm going to make a new rocket. It's like, here we go again. We build the whole launch tower again. So, and it needs to be strong in torsion, as in like, because many of these structures, they can open very fast. It's like, fine. And again, if you really want to see overbuilt, Soviet Union or modern PSLV launch system and GSLV system. And why the heck Soviets were overbuilt like this? This was because early Cold War era, everybody was rushing. So they're like, sir, we do not have that kind of throttle oomph. There is not enough margin that we can turn or twist the rocket. It's like, okay, what if the launch pad turned and twisted? That's why it has that, like, twing. They can turn and twist on the launch pad. And again, a technician can service everything because these clamps have more than enough gantries, more than enough room around it that you can service the whole thing without any hassle. So structural support and constraint, this is another aspect of it. If wind happens, which again, these things are huge, and because they are not surrounded by buildings, we do not get an understanding of it. They are huge. Wind becomes a big of a hassle. That's why you generally have two series of clamps. One would be the main structural clamp. So only when you are starting to fuel it up and it's like, are you ready to go? Yes, you are ready to go. Only then it pulls up. It's like, I got you. Like at that point in time, wind should not cause too much hassle. Because again, if you just clamp it on the bottom and wind starts to blow too much, it will damage the clamp. So structural support and constraint. Even on a Starship, and they're like, okay, the base is like, I got you, fam. It still requires that constraint. That's why the arm is so big and bulky. It's like, it is constraining in two axes. In 3 dimension, one axis is constrained, but like you are a tall structure, it's gonna wiggle like this. So it's like a point. It's just like your long kick. It's like, hey, just stay here. So structural support and constraint. And be mindful, fueling is the most fragile part for the rocket because A, it's going through thermal shock. So it does require pre-chilling and all that, and it is a metal. It is going through like I'm light, easy, featherweight to I have tons of liquid. So it is a fragile state. If you want to understand the fragile, type balloon rockets. Back in the old days, the metallurgy was not good enough, structural engineering was not good enough. They used pressurized air in order to keep the rockets afloat. And once they have at launch period, rocket is like, I got this. Before launch, rocket is fragile as hell. So if you lose the pressure, rocket will collapse. It has happened. And rocket is only strong in vertical axis. All the design match is designed for that. If thrust is going, rocket is like, I can tank 4 Gs. That's not a problem. It's like, I got this. Any lateral vibrations is like, yeah, I can't handle that. It will collapse. So, and it must keep umbilicals safe for second use. That's a bigger issue nowadays. It wasn't an issue in the older days, but now it is an issue. You are gonna launch multiple times a year, so you have to make sure the umbilicals are moved far apart, where it's like fast enough and far apart is like yoink, flamethrower. So this is how the structural engineering will be done with it. It's like, okay, we need these vector points, that too has to be constrained. And every rocket needs new. Heck, even Starship V3, I'm pretty sure for V4 they might have to do some more modification. Now we come to the crew part. Sometimes you need people on boomsticks. That is life. So you do need that, and you need to carry people to heights. These things have elevators. They cannot have stairs. It's too tall. It has to have, again, there is fire emergency escape elevators, but stairs, but you generally have to use elevators. And you must have emergency astronaut slides. Whatever it may be, it has to be there. For example, if SLS, let's just say there is a fire in the tower or fire on the rocket, get into the gondola and yeet, the end. Get into the gondola, the end. Because the gondolas will go into a basically bunker that can handle it. And like, okay, what about SpaceX? SpaceX also has the same thing. The tower is there. There is a string, so to say, like this, but they have a slide. So the astronaut supposed to jump onto that, and I'll have linked the video down below. All human system, including basically space shuttle, they also had that. All human system has one way of yeeting the astronauts if they are not already in the rocket. If they are already in the rocket, emergency escape system can be fired, but that's a very iffy kind of situation. It did happen once with a Russian system. It did happen once, but and space shuttle, yeah, good luck. There is no thing can happen. And space shuttle launch system did had bathroom on the tower, and it's called the world's strongest toilet. It was designed to handle rocket blast. Stainless steel, battle hardened toilet. I'm pretty sure that toilet would be more stronger than Battleship. It was like, bro, I designed to handle rocket exhaust, 130 decibel sound. Not 130, 140 maybe. 140 decibel next to me. I got this. The most strongest toilet ever made by humanity. So fundamentally, if there is a oops event, astronaut must be yeeted out of there as quickly as possible. And astronaut should not get trapped. This is another aspect. This is the difference between Cold War and now. When you are designing tower now, you must have double escape route. As in, if fire happens on the tower burns, okay, what happens to the routes? You're not going to use the elevator at that point in time. What's going to do? Okay, there must be two ways of evacuating the astronauts. Assuming they are not on the top, because generally gondolas are at the top. And that's why the gondolas were chosen. It's like, you do not have enough time to pull, go down, so to say. Fundamentally, all of these has to be accounted for. That's why modern towers are so expensive. Another thing is designed for bulky suits. That's why you will look into space systems. They're generally huge. And you look into battleships, they're like this tiny. It's like, why the heck the space are huge? Because they're relying on the fact astronauts will be much weaker, A, when they're returning, B, when they're going, they're pressurized. The suit is pressurized. So while they do not have the differential they will have in the space, but they have differential. So it's not as comfortable. It's like you are inside a football. It's not comfortable. It's not very flexible. You do not have this dexterity. So you have to design things that are like big, bulky. Like, this is one thing, that science fiction TV shows do not take care. All their handles are like, dude, this is a human handle. A person in an astronaut suit, especially if it's a gas-tight system, will not be able to. Iron Man can, but you can't do that. So you need an exoskeleton in order to move things like that. So it has to be designed with that. Like, all the railings will be big and bulky, easy to grab in spacesuit. All of this. And even the slides are designed in such a way that in spacesuit, you should be able to access it. And must astronaut from high winds. These are basically skyscraper. We don't think of them, but they are skyscrapers. So always you will see there's enough light area, so you can see clearly. There is enough lighting there, so even at night you will be able to use it. But they always have like enough wind wall. Just like, whoa, we are high enough that astronauts can be flown without the rocket. So they're like, hey, let's keep things down. And that's why generally they have crew around there, support crew. Support crew is like, bro, your calorie budget is limited, your energy is limited, save it inside the rocket. I can't help you inside the rocket. I'm going to take care of everything outside of the rocket, locking the system, doing everything that is needed, supply checks, system checks, all of that. So this is the crew part of it. Surprisingly expensive, like surprisingly expensive. Now we come to the mobility part of it, mobile. Rockets are rarely made where they are launched. Rarely. And sometimes its rocket is so big, like if PSLV has to be moved, it can be moved on a, just a platform, just move it, because it's not tall enough. But if you're trying to do that with Saturn V, yeah, it's gonna fall over. It's too tall. So fundamentally, if you're making something that big, that huge, you do need a tower on the mobile platform, as in move the goddamn thing at the same time. That's why crawler was invented. So Saturn V space shuttle, in space shuttle, you could easily see gray caps that were clamping the wings. It was so big, so huge. Again, it was thankfully short, closer to the ground, as in the center of gravity was not high enough. That was the good part. Bad part was it was like flat. It was very hard to clamp, so wing clamps were created. It's like so, and in space launch system, that's a whole different mess. They had to upgrade the crawler's bearing in order to handle the weight. So they do that. And Starship is the most unique system because they're the only one where the rocket is assembled by the tower. There is no rocket before the tower. Tower is the one that's like, I'm going to take the booster, I'm going to put it in the launch clamp, I'm going to take the Starship, I'm going to put it on top of the heavy booster. That's a very unique system. So as of now, that's the only system I have seen, and I don't think that will become common as of now because we don't have any rocket of that size. Even New Glen's upgraded variant is not that big. So it will be Starship only for quite some time. And sometimes buildings are moved from the launch tower. This is the most unique system. For example, if you're in a hazardous environment, let's say there is a lot of rain, there is a lot of sun, there is a bonkers amount of hail, you do not want rocket to tank it. Rocket is not designed to tank it. It's like, bro, I am strong as hell in one axis. Like I can tank 4 or 5G without any issue. Yeah, put a like hailstorm through me, yeah, I'm dead. So they're like, what if I have a building around you? What if I have a building, just like building eats you? A Russian system also has that, like it can just eat the rocket, so to say. So if you need to carry astronaut, everything can be done in a safe environment and then you pull out everything. So Delta ULA systems are also that, like the building pulls back. Like sometimes I find is like, how do you make that calculation? It's like, is it cheaper to move the building or is it cheaper to move the rocket? Like, and again, if you're like, hey, wait a minute, European system looks way too close to Russian system. Yeah, they are almost the same. Soviet legacy. Still, that's going strong. Although we do expect this to be the last or second last. Modern Arians do not require this sort of elaborate grab and twist. So this is the mobile part of it. How the heck you're going to move it? But again, all of this is the reason why you might know the cost of, the rocket cost. It's like, what's the launch tower cost? That's why rocket might be, hey, it's a 20 million. It's like, wait a minute. But all the bomb cost, all the engineering cost, that's rocket cost is barely 10. It's like, yeah, all the substructure that you do not think about. So this was my presentation on basically a launch tower that we generally ignore, but again, it's very important. I hope you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. If you have enjoyed it, please click the hype button. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.